For a long time, alien megastructures have intrigued scientists and amateur astronomers. One major example of this curiosity was Tabby Star, which showed strange dimming patterns that led to lots of observation and debate. Tabby Star, officially known as KIC 8462852, has puzzled astronomers for quite a while due to its unusual periods of brightening and dimming. Many theories were suggested, from comet storms to even alien megastructures, as people try to explain its behavior. Thanks to a Kickstarter campaign that raised over $100,000, recent research has finally provided some answers. In this video, we'll explore all the theories that were considered and explain what scientists now believe is behind the strange behavior of the star. Finding exoplanets has become a major focus of 21st century astronomy, with the transit method being the most popular technique. When an exoplanet passes in front of its star, the light from the star dims for a short time. This is how most of the exoplanets we know about today were discovered. Scientists are used to getting unexpected results when designing missions, but the findings from Tabby Star were truly different. The star's light dimmed significantly, but without any regular pattern. So what was behind this strange behavior? It turns out the answer is actually quite simple. Dust, but in a unique way, seems to be the cause. Since its launch in 2009, NASA's Kepler mission has transformed how we observe exoplanets and other distant worlds. It's observed around 530,000 stars and discovered over 2,600 exoplanets. Among all these stars, Tabby Star stands out as the strangest. KIC 8462852, also called Tabby Star or Boyajian Star, has some of the strangest features in the universe. It shows a 25% drop in brightness, which is far more than what a typical exoplanet could cause. On top of that, it gradually fades over decades, has random brightening events, and lacks the usual infrared emission that other stars with similar dips in brightness have. These unusual behaviors have left scientists puzzled. The first thought was that a planet could be causing the dimming, but no planet is big enough to block that much light. Even a massive ringed planet like a super Saturn wouldn't match the irregular, unpredictable dips that were seen. This ruled out a planet as the cause. Astronomers then considered if it could be a young star with a protoplanetary disk, meaning lots of dust and leftover planet-forming material. Other stars that had similar drops in brightness were young and had these features. However, this theory also didn't fit. Tabby Star was too old to have a protoplanetary disk, and it lacked the infrared emissions that would normally come with that much dust. Because of the strange lack of expected emissions, it was also once called the Where's the Flux star. It was then suggested that it might be a series of comet events, where comets release large amounts of dust and ice as they fall into the inner part of the solar system. This could explain the short-term dips in brightness that had been observed. However, this theory couldn't account for the long-term dimming of Tabby Star. Tabby Star had been observed for over a century, and during that time, there's been a noticeable long-term decrease in its brightness, which this comet theory can't explain. The dust from comets would blow away within a few months, meaning it would take a constant stream of comets to keep the dimming going on for over a century. This would require a huge number of comets in similar orbits, which seems very unlikely. So, what could be causing all this? This brings us to the last theory, one that has caught the interest of many conspiracy theorists: the possibility of an advanced alien civilization blocking the star's light. This theory is definitely one of the most popular and has drawn a lot of attention over the years. After all, when something mysterious happens in space, some people tend to think aliens are involved. But let's explore this idea too. The hypothesis is that an alien civilization, much more advanced than humans, was building some kind of massive structure around the star, like a Dyson sphere. The concept of a Dyson sphere was first proposed by the American theoretical physicist Freeman Dyson. It's a theoretical advanced structure that could surround a star and capture all of its energy, providing an unlimited energy solution for space living and production. As the construction of this megastructure neared completion, it would block more and more light from the star. Over the past century, the star's light dimmed significantly, which some thought could be due to the structure being nearly finished. While this idea seemed far-fetched to some and fascinating to others, it ultimately wasn't true. A Kickstarter campaign helped scientists conduct a recent follow-up observation, which showed that this hypothesis was wrong. But why couldn't it be aliens causing the dimming of Tabby Star? Despite all the speculation, SETI, the organization searching for extraterrestrial life, hasn't found any signs of alien activity. and this holds true for Tabby Star as well. The reason is that a structure built by aliens would be completely opaque, blocking all light. This is also true for other solid objects like planets or moons orbiting the star. Over the last 3 years, astronomers studied more than 20,000 images across 4 different wavelengths, from ultraviolet to infrared. By tracking the dips in the star's light as they happened, they were able to rule out the possibility of an alien megastructure. With this information, scientists could observe dips in light across all wavelengths. If these wavelengths were similar, it would indicate that something solid, like a planet or star, was blocking the light. However, after analyzing 4 different dips in the light coming from Tabby Star, astronomers noticed that the dimming was more pronounced at some wavelengths and less so at others. Now, this pattern suggested that the cause of the dimming was not a solid object. The new data shows that different colors of light are being blocked at different levels. So, whatever is between us and the star isn't opaque, like you'd expect from a planet or an alien structure, explained Boyajian, the scientist who first studied the star. So, what was actually blocking the light? The blue wavelengths were consistently blocked during all dimming events, from short-term dips to the long-term fading of the star. The only explanation for why blue light is blocked while red light gets through is the presence of dust particles. This means that whatever caused the dips and the long-term fading had something to do with dust. A newly published research paper suggests that the dust around Tabby Star is made up of very small particles, around 0.1 microns in size. This means that stellar radiation pressure could blow these dust particles away, indicating that the dust clouds formed within just a few months. The latest infrared observations showed at least a 12.4% plus or minus 1.3% dust coverage, which is part of what we call secular dimming. This supports the idea that the dimming is caused by dust surrounding the star. The evidence points to dust as a culprit, but there's a twist. Normally, dust around a star means it's quite young. However, Tabby Star has been shining for millions of years and is well established in its life cycle. The dust we see shouldn't last long, only a few months, unless it keeps getting replaced. Now, there are 2 main ideas about why this might be happening. One is that there could be an external dust ring with dense clouds of dust around it. The other possibility is that something outside the star is blocking its light. Since 1890, we've seen a decline in the brightness of Tabby Star, and this trend has continued into 2018. But the dimming isn't consistent. There are brief dips that last a day or less, mixed with longer dips that last for months. This pattern definitely points to dust particles that are as small as 100 nanometers. Astronomers have ruled out the idea of aliens and suggested that circumstellar dust is causing the dimming of Tabby Star. They're still trying to figure out the type and source of this dust. However, some believe that the star might be dimming and brightening on its own without anything blocking it, a possibility that the new data doesn't dismiss. Another theory is that the dust could result from a sort of stellar indigestion. If a giant gaseous exoplanet, about the size of Uranus, were swallowed by the star, it might be responsible for the dust we're observing. Centuries ago, this planet could have spiraled into the star, causing it to brighten before returning to a more stable state. The dips in brightness we see might be due to debris from the past disruption or the evaporation of smaller bodies. No matter the cause, one thing is clear: the dimming of Tabby Star is caused by dust. Now, while the wild theories about Tabby Star might be wrapping up, the research it inspired marks a new chapter in astronomy. Tabby Star highlights the value of citizen science, showing how everyday people can support larger research efforts in the field. So, what's next for Tabby Star? Well, there's still a big question about where all this dust came from. It can't all be interstellar dust. Did a planet get swallowed by the star? Even though the idea of an alien megastructure might be off the table, Tabby Star will remain a fascinating mystery. Now, let's delve into another captivating space mystery that has intrigued scientists and space enthusiasts alike: the enigma of the WOW signal. Discovered in 1977 by astronomer Jerry R. Emmon while working on a SETI project at Ohio State University, the WOW signal represents one of the most compelling pieces of evidence in the search for extraterrestrial intelligence. The story begins on August 15, 1977, when Emmon was analyzing data from a radio telescope known as the Big Ear. Now, this telescope was designed to scan the cosmos for radio signals that could indicate the presence of intelligent life beyond Earth. As Emmon combed through the data, he noticed a remarkable anomaly: a 72-second burst of radio waves originating from the direction of the constellation Sagittarius. The signal had characteristics that made it stand out from typical background noise, including its frequency of 1,420 MHz, which is the natural emission frequency of hydrogen, the most abundant element in the universe. What made the WOW signal particularly intriguing was not just its strength, but its unmistakable pattern. The signal was consistent with what researchers might expect from a non-terrestrial source. In a moment of excitement, MN circled the alphanumeric sequence of characters representing the signal on a printout and wrote WOW in the margin, giving the discovery its enduring name. Despite attempts to follow up on the signal and detect a repeat, no similar signals were ever received again. Now, this led to speculation about the signal's origin. Some theorists proposed that it might have come from a distant civilization attempting to communicate, while others suggested more mundane explanations, such as interference from Earth-based sources, or even a natural astronomical phenomenon that remains poorly understood. Over the years, various hypotheses have been put forth to explain the WOW signal. One of the more popular theories is that it originated from a comet passing through the area. In 2012, a group of astronomers from the University of California, Berkeley, suggested that the signal may have been the result of the hydrogen emissions from a comet called 266P Christensen, which was near Earth at the time the signal was detected. They argued that the signal's frequency matched the expected emissions from such a comet. However, while this explanation is plausible, it's not been definitively proven, and the signal's characteristics do not fully align with what would be expected from a comet. Another hypothesis suggests that the WOW signal could be the product of a powerful burst of radiation from a natural astrophysical source, such as a pulsar or a quasar. Pulsars are rapidly rotating neutron stars that emit beams of radiation, which can be detected as periodic signals from Earth. However, the signal from the WOW signal did not exhibit the same periodicity typically associated with pulsars, leading many to dismiss this explanation. The ongoing mystery of the WOW signal has sparked a flurry of interest in the scientific community and beyond. It's inspired a range of investigations, with researchers looking for patterns in the signal that might provide more clues. In 2017, a group of researchers attempted to analyze data from the Green Bank Telescope in West Virginia, revisiting the original frequency to see if they could capture any similar signals. Now, despite their efforts, they were unable to detect any signals that could replicate the WOW signal. The search for extraterrestrial intelligence, or SETI, has evolved significantly since the WOW signal was first detected. Advancements in technology and data analysis techniques have enabled scientists to scan the skies more efficiently and effectively. New initiatives and collaborations have emerged, aiming to refine the search for potential signals from intelligent life. Projects like the Breakthrough Listen are using powerful telescopes and artificial intelligence to sift through vast amounts of data in hopes of finding something akin to the WOW signal. In addition to the technical challenges of capturing such signals, the interpretation of what constitutes evidence of extraterrestrial life remains a topic of debate. The WOW signal may represent a tantalizing glimpse into the possibility of life beyond our planet, but it also serves as a reminder of the limits of our understanding. The universe is vast and full of complexities that we're only beginning to grasp. As we continue to explore the cosmos, the WOW signal remains an enduring symbol of our curiosity and drive to understand our place in the universe. It's ignited imaginations and fueled discussions about the possibility of intelligent life beyond Earth. Whether it's a sign from an advanced civilization, a product of natural phenomena, or simply an unanswered question, the WOW signal continues to be a fascinating mystery that captivates the minds of astronomers and enthusiasts alike. While the WOW signal remains unresolved, it spurred the exploration of various celestial phenomena that could help unlock more secrets of the universe. One such mystery is a potential for communication through pulsar signals. Scientists have suggested that if intelligent life exists in the universe, they might use pulsars as cosmic beacons, utilizing their predictable and consistent emissions to send messages across vast distances. Pulsars, with their highly regular rotation rates, emit beams of electromagnetic radiation. Some researchers have proposed that intelligent civilizations could modulate these signals to convey information, similar to how we use radio waves for communication on Earth. The idea is intriguing, as pulsars can act as natural markers in the sky, providing navigational references for interstellar travel. If civilizations can tap into this potential, it could pave the way for communication that transcends the limitations of our current technology. Furthermore, another captivating mystery in the realm of space exploration is the search for exoplanets, particularly those in the habitable zone. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions might be just right for liquid water to exist, a critical ingredient for life as we know it. The discovery of potentially habitable exoplanets has accelerated significantly, with missions like Kepler and TESS, Transiting Exoplanet Survey Satellite, identifying thousands of candidate planets. Among these candidates, some have piqued the interest of researchers due to their similarities to Earth. For instance, Proxima Centauri b, an exoplanet orbiting the closest star to our solar system, has garnered attention for its location within the habitable zone. Scientists are eager to understand whether such planets have the right conditions for life, and efforts are underway to analyze their atmospheres for signs of biosignatures, chemical markers that could indicate the presence of life. In addition to the search for exoplanets, scientists have also focused on understanding the conditions necessary for life beyond Earth. The study of extremophiles, organisms that thrive in extreme environments on our planet, has expanded our understanding of the potential for life in harsh conditions. These organisms have been found in extreme heat, pressure, acidity, and salinity, prompting researchers to consider that life may exist in environments previously thought to be inhospitable. One fascinating example of an extreme environment is Europa, one of Jupiter's moons. Europa is covered in a thick layer of ice, beneath which scientists believe lies a vast ocean of liquid water. The potential for subsurface oceans on moons like Europa raises exciting possibilities for microbial life to exist beyond Earth. Missions like NASA's upcoming Europa Clipper aim to investigate this moon further, analyzing its surface and subsurface for signs of life. The search for extraterrestrial life continues to unfold as we develop better tools and technologies for exploration. Space telescopes like the James Webb Space Telescope are set to revolutionize our understanding of distant worlds, allowing scientists to analyze exoplanet atmospheres and search for chemical signatures of life. The JWST's ability to observe faint signals and capture data on distant galaxies may yield breakthroughs in our search for extraterrestrial intelligence. Moreover, the advent of private space exploration companies has brought a new dimension to the pursuit of understanding the cosmos. Companies like SpaceX and Blue Origin are working to lower the cost of space travel and make it more accessible to researchers and the public. This democratization of space exploration could lead to collaborative efforts that enhance our ability to search for extraterrestrial life. Now, as we contemplate the vastness of the universe and the potential for intelligent life beyond our planet, the WOW signal stands as a pivotal moment in our quest for answers. While we may not have definitively identified its source or meaning, it serves as a reminder of our insatiable curiosity and the inherent drive to explore the unknown. The quest for understanding does not merely lie in the realm of radio signals and exoplanets. It extends to the search for cosmic phenomena that challenge our current understanding of physics and the nature of the universe itself. For instance, black holes, regions of space-time where gravity is so strong that nothing can escape, remain some of the most perplexing objects in the cosmos. The study of black holes continues to push the boundaries of our knowledge, and they've become focal points in the quest to understand the fundamental laws governing our universe. Now, we'd love to hear your thoughts on this in the comment section below. And if you've enjoyed this content, please like the video and subscribe to our channel. Thanks for watching.